So today we talk about hyperbolas, and again, like yesterday's video, something that's super important to know is everything is based on the center, which you learned from yesterday was your HK. So that's very important. There are two kinds of hyperbolas that we'll be talking about in our class. The first kind of hyperbola that we're going to be talking about is one that opens up left and right, or horizontally. What you'll notice is if it opens up horizontally, the x thing will be coming first, period. You don't have a choice. If the x thing comes first and is positive, then it opens up horizontally. And then the second kind of hyperbola are the ones that open up vertically. That'll happen when the y thing comes first. And you'll notice that in our x and y situations, that it's very important to know which one comes first. And it also has to be positive. So number one, it has to be first, and number two, it has to be positive. Just like in ellipses, your equation will always be equal to 1. Just like in ellipses, you'll have two squared parentheses with numbers underneath them. Okay, this is very important. So when you get everything equal to 1, find out which thing comes first. For example, if I were to see something like the following, blah, 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 x minus 3 squared over 10 minus y plus 2 squared over 5 equals -1. Is that in its standard form?
No.
No. How come?
Because the one's negative.
It's a -1. So if I were to multiply everything by -1 on both sides of the equation, which parentheses would really come first?
Y.
The y parentheses. Because all of the signs on the right and all of the signs on the left would change, and this would be rewritten as y plus 2 squared over 5 minus x minus 3 squared over 10 equals +1. So be aware, no matter how they present it to you, in the end, when you get done, whatever comes first needs to be positive. So you make sure you rearrange it so you know which one's positive and first, and that'll tell you which way the hyperbola opens. All right, let's try some problems because, as usual, that's what I believe works best to understand this material. So look at number 1. In number 1, I notice that we have an x squared thing, a y squared thing, there's a minus in the middle, and it's equal to 1. That's what tells me I have a hyperbola. Which thing comes first and is positive? The x thing. That means I know that this hyperbola will open like this, or in other words, horizontally. So in my mind, as I'm thinking about this, I'm thinking, oh, I've got to have this thing opening up horizontally. Then everything starts with my center. So I name my center. My center is whatever makes the parentheses 0, just like in ellipses. So 5 and -1. When I draw this thing with 5, -1, I'm going to redo my axes here because I don't like the way that they have these. So give me a second here. I'm going to redo that. So if I redo my axes, knowing that I'm at 5, -1, I'm going to do the following. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3. And my center is at 5. 1, 2, 3, 4, 5, -1. And I put my center there. Just like with the ellipses, my center is not part of my hyperbola. But it will be extremely helpful to have that center because everything, again, is based on the center. Now, after you get done with your center, you're going to find vertices. Hyperbolas, unlike ellipses, do not have covertices. They just have vertices. That's it. Like a parabola. There are no covertices. So next I find my vertices. The way that I find my vertices is I look at whichever parentheses was positive. In this particular case, I noticed that my x parentheses was positive. So I look underneath the x thing, and I see the number 25. And you know how in ellipses we talked about a squared, b squared, and c squared? And the bigger number was always the a squared? In this case, whichever thing is underneath the positive thing will be the a squared. Or in other words, has to do with your vertices. So I look underneath the x thing, I see 25. What does that tell me? That tells me that from my vertex, I am going to go left and right 5 units. So plus or minus 5 from my center. So I go 5 to the left, and that would put me over here. And if I went 5 to the right, that would put me over here. I can write down, this is just not, I'm going to redraw my graph, I'm sorry. The graph is correct, but you can't see the other part of the hyperbola if I do it this way, so I'm just going to redo it. My apologies. Holy! That's not what I wanted. That'll be fun to watch on the video, though. Kind of funny. All right. Okay, so back to our graph here. I do have my center at 5, -1, 1, 2, 3, 4, 5, -1, so that's right here. Oops, probably should do that in blue. Here's my center. And then my vertices will be at 0, -1. So I'll put that down over here. 0, -1. And at 10, -1. 6, 7, 8, 9, 10. Okay, so those are my 2 vertices. After I find my vertices, what I'm going to do is I'm going to write equations of my asymptotes. And I want you to watch something, and I want you to tell me if you can figure out what this means. So as you look at these orange asymptotes, what I want you to notice is the stuff on the left is always y stuff. It came right out of the equation that we were given. And then the stuff on the left in the parentheses, the x minus 5, also came directly out of the equation that we were given. The 3 over the 5, which represents the slopes of the asymptotes, is always the square root of the y thing over the square root of the x thing. Let me write that down. Square root of y over square root of x. And what I mean by that is I'm talking about in the equation under the parentheses. So look under the x parentheses. You will see 25. The square root of 25? 5. Under the y parentheses, you will see a 9. The square root of 9? 3. And remember, slope is rise over run. So the rise is in the y direction, and the run is in the x direction. And that's why the rise, which has to do with the y thing, the square root of 9, which is 3, goes on the top, rise. And the square root of the x thing, which is on the bottom, 5, goes on the bottom because that's the run. I like that. So this orange equation of the asymptotes is in point-slope form. Point-slope form. Let me show you how that helps me. Pause from your writing for a minute. I'll come back and give you time to write point-slope form. Look at my center, the blue dot. Do you see the blue dot?
Yeah.
From my center, if I look at my asymptotes, the point that we used in the point slope form is the point 5, -1. What's that?
Center.
My center. And the slope, there are two of them, 3/5 and -3/5. That means to get to the next point in one of my asymptotes, I would rise 3 and run 5. Or in other words, I would go up 3, 1, 2, 3, and go right 5. And this would be the other point. What does that mean? That means I would graph one of my asymptotes like this. That's an asymptote. The other part of my point slope formula, where I have two asymptotes in the orange, means that I would go down 3 and right 5. So from my center, I go down 3, 1, 2, 3, and right 5, put a dot, and that's the second dot for my second asymptote, which also goes through the center, which would now look like this. So now I have two asymptotes that came out of the orange equation. Okay, now the reason that you did these asymptotes is this. Look at how easy it is for me to draw my hyperbola. Oh, by the way, remember, asymptotes are something you get really close to and never touch. There's my hyperbola. You start at wherever the vertices are, get really close to the asymptotes, but don't touch them. Me too. I like you. All right, the last thing we have to find are foci. Our foci in hyperbolas are a little bit different than in ellipses. Yesterday you learned that in ellipses our foci equation was c squared equals a squared minus b squared, and I told you that the biggest number always comes first, right? The cool thing is, in hyperbolas, it looks like this. C squared equals a squared plus b squared, which looks like the Pythagorean theorem, and it actually doesn't even matter which number comes first. Okay? So in this case, the a and the b are the numbers that are underneath the parentheses. In our parentheses, we had the numbers 25 and 9. So c squared equals 25 plus 9. 25 is a squared, 9 is b squared, or in other words, a and b were 5 and 3. I don't really think about a's and b's, to be quite honest, you guys. I think about it in relationship to the equation I'm given. So I know, like when I'm doing my asymptotes, it's always the square root of the y thing over the square root of the x thing. And I always know that whatever comes first is going to be the positive thing. I don't really think about a's and b's. In this case, c squared equals 34, which means, of course, that my c has to be plus or minus the square root of 34. Now, like yesterday, this is not really a great situation as far as like square root of 34 working out to be an integer, but I do know that the square root of 34 is pretty close to the number square root of 36. And the square root of 36 is 6. So I know that this thing, whatever it is a little bit less than 6 units away from the center. It's somewhere more than 5, but less than 6. So I go to my center, and I count out somewhere between 5 and 6 units away from my center. So to the right I'd be 1, 2, 3, 4, 5. Oh, that's the vertex, right? And a little bit more than that, but not to the next point, or the next mark on the axis. So my focus is right there. To the left I go 1, 2, 3, 4, 5. Oops, vertex, a little bit past that. Focus. As long as you're close on your graph on the test, I'm going to be fine, because what I'm going to look for is off to the side here, when you write down your foci, remember, you started at the center, and which part of your center was affected, the x or the y direction?